I'd like to look at a few other simple examples of solving trig equations. Okay, first of all, I'd like to solve secant of theta plus the square root of 2 equals 0 on 0 to 360 degrees, and then give all solutions. First of all, you see that because they're asking for the answer on 0 to 360, that they want the answers in degrees. Okay, take your trig function, or trig equation, and the first thing you want to do is you want to solve it for secant. So I'll subtract over the square root of 2. So we have secant of theta equals negative the square root of 2. From here, I know that secant of theta is equal to the value r over x. Okay. On this particular problem, I actually need to rewrite the value that I have so that r is positive. I have here that the negative is going with the square root of 2, and I know that's not proper since r is on the top. So I'm actually going to rewrite this as the square root of 2 over negative 1, and then that way you can see exactly what the values of r and x are. Now from here, I'm going to draw a triangle. Like I said, most of the times we're going to end up with two different angles as a solution. Okay, this particular problem, I have that x is a negative 1, r is a positive. R is always positive. Which quadrants is x negative in? X is negative in quadrants 2 and quadrants 3. So we know those are the quadrants that we want to draw our triangle. So I'll draw triangles in both of those two quadrants. I don't really care that you're drawing your triangles accurately as far as a distance from the x-axis, but I do care that you label them properly. Okay, the r value is square root of 2. So we have square root of 2 and square root of 2. The x value is negative 1, and that'll be true for both triangles. We now see that this is a special triangle. We know that our reference angle on the inside is actually 45 degrees, which makes this side 1, and then in the third quadrant, that side negative 1. Both of those are 45-degree angles. Now, make sure that you realize that the answers for these trig equations are always measures from the positive x-axis around to the terminal sides. So there's theta 1. Theta 2 is going to be the measure from the positive x-axis around. Okay. That being the case, then we need to do a little bit of arithmetic to get these two answers out. Alright, theta 1 is going to equal 180 degrees minus 45 degrees, which is 135. So there's the answer that's in quadrant 2. Theta 2 is going to equal 180 degrees plus 45 degrees. And so that answer would end up being 225 there in quadrant 3. Okay, so the solutions are theta 1 equals 135 degrees and theta 2 equals 225 degrees. Those are the solutions over 0 to 360. Okay, it also asked to give me all solutions, and so all solutions would look like this. Theta 1 would equal 135 degrees plus n times 360 degrees. And theta 2 would equal 225 degrees plus n times 360 degrees. Now you have to be careful. Every single problem that we have worked up to this point, we have always been solving for a single angle. Single angles are very straightforward. This is the way that they're always going to work. The problem is when we get down to double angles or half angles or triple angles, then what I'm showing you here at the end is going to change slightly. Let's look at another example. This example asks us to solve tan of theta plus 4 equals 5 on the interval from 0 to 2 pi. Okay, first thing, I want to solve by subtracting over 4. So I have tangent of theta equals 1. Okay. In this situation, I have to be extremely careful because I know that tangent is equal to y over x. Y and x can either be positive or negative, and it totally depends on the value that I've gotten for the tangent. In this case, I have that tangent is equal to 1. Well, we have to be careful here. 1 could either be written as 1 over 1, that would give us our y over our x, or, because the signs on x and y are not restricted, you could use negative 1 over negative 1 as your y value and your x value. And so that's how, in this case, we are coming up with 2 triangles. The only time you won't come up with 2 triangles when you're solving on 0 to 2 pi is if your answer is a quadrantal angle. Alright, on here, which quadrants are x and y positive in? X and y are positive. They both have to be positive in quadrant 1. Where are the quadrants where x and y are both negative? X and y are negative in quadrant 3. And so those are the 2 quadrants I want to draw these triangles. One here, one here. Okay? We know that in the first quadrant, x is 1 and y is 1. That's a special triangle. The hypotenuse is square root of 2. In quadrant 3, x is negative 1, y is negative 1. That is also a special triangle, square root of 2. The actual values, we would have theta sub 1 being the angle in the first quadrant, and then we'd have theta sub 2 being the angle in the third quadrant. Okay, theta sub 1 we know is a 45-degree angle. Theta sub 2 we know is 180 degrees plus 45 degrees, which is 225 degrees. Okay, this particular problem asked for the answers in radians. Okay, so over the interval from 0 to 2 pi, our answers are theta 1 equals pi over 4, and then theta 2 equals, you can think about on the negative x-axis, pi is the same thing as 4 pi over 4, and so this particular angle as a 45-degree reference angle would be 5 pi over 4. So theta 2 is 5 pi over 4. There are our solutions. This concludes this example of solving trig equations.